Agentic AI, AI agents. We've heard it a million times. Is it all hype? Are these agents only there to protect the AI bubble, or is there actual substance here? Let's take a look. It's tough to clearly define what an agent is. One definition I like is that an agent is an LLM in a loop that runs actions, observes the result, evaluates it, and keeps iterating until the task is completed or we've burned enough tokens. Does it still feel hazy and abstract? Let's take a look at an example. So this is what I like to call the $1 trillion loop. So this is a very basic coding agent. So we have a loop with the maximum number of iterations, so we don't run indefinitely. And we have a system prompt that instructs the LLM to be a helpful coding agent. Then we have the task, which could be writing a function or writing a class. We generate the code, then we run it in Sandbox to collect as many signals as we can, such as compilation errors, logs, outputs, what have you. And then all this is passed to another LLM that's going to act as an evaluator. So we give it all the necessary information and we ask, did the solution meet the task? Answer yes or no, and also explain. So the evaluator runs, and if there is yes in the assessment, then we are all done. If not, we indicate that we failed, and we also provide the assessment with the explanation. All this is given back to the initial LLM so it can try again, but now it has more insight. And this is very powerful when you think about it, because how this differs from traditional software is in two key areas. The first one is that the action that we are taking, which is generating code, is based on intelligence. So there is some sort of intelligence there. And in addition to generating code, you can have other types of actions. And then once the action is run, once it interacts with the environment, we have an evaluation step where there is an assessment to see if we completed the task or not. And if we did not, we provide an explanation, and then we try again. And so these two steps in the middle unlock the power behind agents. Let's keep in mind that this does not always work, that sometimes the model goes down rabbit holes and it gets stuck and it hallucinates and it produces garbage. And so this is not a silver bullet, but this is the main idea behind the agent loop, that you can run actions that are pretty flexible and that you can evaluate these and iterate until you complete the task. So with coding agents, billion-dollar startups are just a prompt away. But there is a catch. You need to include make no mistakes in your prompt. Jokes aside, I think coding agents are a counter-argument to the it's all hype narrative, and the fact that people are willing to pay for these, and that the Cursors and Anthropics of the world are racking up millions and millions of revenue, is there is a legitimate demand for them. And I think they are pretty useful, especially when you're prototyping or when you're getting started with a familiar language or framework. And actually, the more capable and more knowledgeable you are, the more you can get out of these. But they are still not quite there yet, and hallucination is a thing. So tread carefully. So the basic idea is that you launch an agent in your terminal or in your IDE, and then you describe what you want it to accomplish. You can even ask it questions about an existing code base, and it can either create a new feature or make changes to existing files or spin up a whole new project. And when you look at the output, it's actually outlining coherent steps, and then each step is potentially taken care of by a sub-agent, and there are multiple tools involved, and the evaluation is more subtle, but at its core, it's just that magical loop. Another interesting application of agents is computer using agents, and these are models that actually interact with the computer. And so recent generation of LLMs are capable of seeing and understanding images. And the models have also been fine-tuned on outputting computer-specific actions. So the model can output the action name click on pixel at coordinate XY, and then the host environment, the Python code, for instance, that's calling the LLM is going to actually carry out that action. And the way these computers using agents work is that the LLM is given a screenshot of the computer, and then it outputs the name of an action such as clicking or inputting text into a keyboard or whatever. And the host environment runs that action, and then it takes a screenshot of the result and it feeds it back to the LLM. And we keep running this agent loop basically until the task is accomplished. And it's an impressive application of the agent loop. And if we replace the computer actions with humanoid robot arm actions and screenshot images with pictures from the real world, from the humanoid robot camera, we actually have a humanoid robot agent. So there's this cool blog post that draws distinction between agents on one side, which are more flexible, more autonomous, but by definition unpredictable, and so their errors can compound and they are not that reliable. On the other side, we have workflows which are less flexible, and so we have a predefined code path, but we have better guarantees and they are less error prone. And so they recommend always starting with a workflow and only adding complexity and more autonomy when needed. So in the blog post, they discuss certain patterns that emerge when building AI applications. So for instance, you have the routing pattern when you have a central model upstream of more specialized models such as coding model or a thinking model. And based on the user's query, the model is gonna redirect that prompt into the more specialized model to get better results. We also have the parallelization pattern where we can run the same prompt multiple times in different models to get the maximum amount of insight. And this could be useful for tasks such as scanning code for vulnerabilities or moderation, or tasks that we want to get the maximum amount of information and insight possible. There's also the Orchestrator-Workers pattern, where if there is a large task, such as deep research, where we want to look through dozens and dozens of links, putting the content of all these web pages into a single LLM is not going to perform very well. So we divide the work into subtasks, and then we spawn workers, and each worker is going to take a subtask, and the result of each worker is going to be synthesized in a final model that's going to give us the summary of all the results. So where do we go from here? We know for sure that developers are determined to code themselves out of a job. I mean, the most successful agents are coding related. There is definitely a lot of hype, but it's not completely baseless. It's just that the progress is slower than advertised. I think a good stance to have is to be realistically optimistic, but also to be able to separate the wheat from the chaff and to be cautious of the overhype. So the bear case is that we're going to remain in demo purgatory and we're going to keep shoehorning contrived agents, and the internet is going to be filled with AI slop and institutification is going to reign supreme. The bull case is that tokens are going to get cheaper, models are going to become better, agents are going to get way more useful, and we're going to access incredible prosperity. What is going to be? Who knows? Anyway, I hope this has been informative. Thank you for watching. Bye-bye.